Hello and welcome back to the Microsoft Fabric Training 2023. And in this module, what we will do is we will cover up the Apache Spark to use in Microsoft Fabric. And in order to do that, as you can see that Apache Spark is an open source platform that that is used for the large scale data processing, and it uses the code and scheduler to extract data and implement. So what we will do use is we will use it in the Microsoft Fabric and embed that to fetch the data based on multiple data sources, and it can we can further process it and um, visualize it as well. Moving on to the next slide, it's just a theoretical overview that I'm giving, and then we will do the practical by going into the workspace and create the notebook and execute the notebook. So as I mentioned before, that Apache Spark uses open source parallel processing for large scale data processing and analytics, and it has become popular in terms of big data processing scenarios, and it's available in multiple implementation that includes Azure HD Insight, Azure Databricks, and Azure Synapse as well. So now it will be same as the implementation of Spark will be same as other data platforms. So we can we can just see that if you learn implementing in Microsoft Fabric, you will also be able to do it in Databricks, Synapse Analytics as well. What's the preparation to use the Apache Spark? So Apache Spark uses the divide and conquer approach to process large volume of data quickly. So all we need to do is we need to submit the data processing job through the code, and then Apache Spark uses the cluster management or cluster management module to utilize and distribute the processing of the data. So you don't need to worry about large data processing and large volume of data. So all you need to do is you need to submit the data processing job by writing some codes, and the code I mentioned is you can either write it in Python, Spark, Java, Scala as well, and Spark SQL or PySpark. It is the Spark version of the Python. Um, so in Fabric, most data engineering and analytics workload are accomplished using the combination of PySpark, which is the variant of Python, as well as Spark SQL, because we are fetching data, we are fetching the data and putting it in the notebook. There are a couple of settings which we'll be going through uh, in the workspace. So this is just an example of what needs to be done here is that there are three categories which we need to explore. One is the node family, the other one is the runtime version, and then the next one is the Spark property. So node family is a type of virtual machine that uses Spark cluster node, and this is memory optimized and provide optimal performance. The runtime version displays the latest version of the Spark and its sub dependents and sub component. Mm, Other than that, I think there are some other properties like high concurrency as well as automatic tracking of machine learning experience as well. We will be going through the workspace settings once we set up the Spark Compute in the the practical version while implementing. So let's head to the practical approach of doing that. As you've seen in the previous video, we've created a test fabric workspace, and in that workspace, we've created lakehouse, we've created data warehouse, we've also imported, the a dummy data as well, and in that dummy data, we've used sales data pipeline as well as creating a sales report as well. So now what we'll use our existing lake house in that. and in that we will embed some value and extract some values in that. So if you go to the lakehouse test fabric, and we have created a sales table here. So now what we will do is we will use some value. We will use the data related to orders. Just import that data in the lake house. So I'll share a link to the GitHub raw data with you. But in order to upload these files, what we will do is we will go to the files, the get data link, and create upload files. So now the files have been uploaded, but we have previous data as well. So what we'll do is we'll create a new folder here, new subfolder, and name them as orders. And in that orders, what we'll do is we'll just drag this file one by one to the orders folder. And if you can see, when we explore, we'll have the all the CSV files related to orders in that order folder. So in that lake house, we'll see these three files. We will also have the menu item to refresh, getting data with a new pipeline and new data flow, as well as new Power BI data set. So we can create the data set based on directly from these files. There's an option to see as open notebook. So we'll just do an open notebook, and from that menu, we will select new notebook. So this will ask for a sensitivity label, and it will create a new notebook based on that. And if you see here a lake house, all the tables and data will be there in the branch, as well as it will create a notebook environment to write a code and do something uh, related to Apache Spark. So there are some options related to code. One was the code or markdown. We can also have a markdown cell as well as clear output, as well as the other things related to that. And there's an option for each cell to play around as well. So we click on code, it will create a new cell. And as you can see, the language here is PySpark, which is Python. We can use switch to another other languages as well. So now what we'll do is we'll create a heading, and then move on to enter code. So this is we'll add another cell, and just type sales order exploration, and then convert it to the markdown cell. So what this will do is it will create a, a formatted text, and this is heading one. So now what we'll do is when we'll press enter, pull enter, so it will, sorry, we're just connecting it to markdown. And then once you edit this, and this will show up as the sales order exploration. This is the code version of it. You can convert it to markdown, and you can convert it back to the code as well. So now what we will do is we will load the data to the file, do this using the data frame. So starting off with df equals spark dot read format, and this format is CSV dot option. And this option, we are saying that the header, the first row is has a head as a header. So header comma Control enter. So the second thing, this what I'll do is I'll just type true. I'll just stop this because I accidentally executed and it's showing it as error. Now after that, header true, we just load and then specify the path of it. So if we see here, orders, and we will be loading CSV file, copy API path. And then just because we are in the same lake house is already loaded, so we will just using the relative path of files.orders/csv. Now we'll execute it. So this will execute, and it says execution succeeded. We can also check logs as well. It's technical logs. We can specify this. Now we can do is we can display the data here. So display df, and then control enter will run the code. It will show up the CSV file data as well, taking first row as headers. But you can see that the first data is showing as a header, so we don't see that the headers are there. So default we are doing is we are just using it as true. But if you see the data and explore, there's no headings apart from the index column. So instead of using first row as header, we'll just rerun this code as false and then rerun this again. So now what we'll do is it will give the name of the header of wherever this is available, but other it will just give C1 C2 as headings. So there are three, four columns here. Fifth one is the index. Now we will assign a schema based on, or the table structure based on the the columns type and stuff. So in order to do that, we'll open up and we will see that how it will load the data. So we need to import a library called pyspark.sql. pyspark.sql dot types import all star. And what we do is we'll do order schema equals struct type, and then sorry, give some error. Sales order number, and this is string type. The other one is the second one is the sales order line number, which is the which can be the integer type as well as order date as well as the location, email address, everything. So I'll just copy paste this code. It is available in the comment section or the video description as well. So initially what we did, we we give a CSV file and then we selected this option. Now we'll copy this, paste it here. Instead of using option, we will use dot schema, and then in that schema we will put up order schema. and then we will use df dot df dot display dot df. Now we'll execute. It says widget id not found. um, this is because I have not executed this completely. So once I'll execute this completely and then execute this, it will show up the tables here. So this is sales order number, sales order line number, order date, customer name, and so on. The emails and all the stuff with the same, text, unit price, and format. So all schema is being defined based on each of the column. So make sure the order of the schema is same, order of the columns are same, as well as the formatting type. Um, so now currently we have only 2019 CSV file, but the structure of the CSV files are same. So if we use a wildcard, like for example, use static here and run this code, this will also load the data with all the CSV records. And so instead of 2019, we can use the 2020, 2021 as well. So the complete data will be there and loaded in terms of the modified code with the uh, complete 3 years of data. Next step, what we'll do is we'll create a what we create we'll create and explore some data in the data frame. Then let's just add this another piece of code. So now what we'll do is we'll just count some details about it. So we'll count the customers. So customer equals data frame, and the field name is, you can see here. Let's check. So this is customer name. So we are just using this name as to find out customer name, and we're also checking email. And this is, we are just printing customers dot count. Let's check what happens. It says customer name is not defined. So customer name. So make sure this is um, case sensitive, and we are using the wrong parenthesis. So in order to explore the columns, we will not be using round brackets. We're using flat brackets, the square brackets. So this is saying customer count as 32718, and we'll use another query where another count which just says customers dot distinct count, and then we'll execute this. So 32718 is distinct, complete, and 124727 is distinct. Um, so when you perform this operation on a data frame, the result is a new data frame which is called the customer. So the customer has become a new data frame, and we can apply all the operations that we can do in um, a data frame for custom, like counting, maximum, minimum, all the values related to that. We can also use print, and we can also use, since now we are adding another piece of code, and we can also use display customer dot customers dot distinct. Now we'll execute this and we'll see it will display the records of all the distinct customers, which is around 12,000 records. So yeah, so it's just showing current 1,000 records, but generally it is 12,427. You can also export this result to a CSV, JSON or XML. You can also view chart as well associated with that. So this chart would not be relevant in certain data points, but can be an easy peek of the view what needs to be looked into. Moving on to the next step, what we are doing is we want to view a specific, I mean all customers for a specific items. So in this way, if you can see, if I go back and if I see, if I go back and if I display the data frame with the values along with that, this is so if I'm just doing df and then executing this again, so it is giving me the customer name, order date, sales order, quantity, unit price, the item. So if I want to search specific, for example, let's search for mountain to 200 silver 42, and if I use this mount item, we can apply a filter associated with that. So we'll use this same code as we've used previously and copy and paste it here. And then what we'll do is we'll just apply where clause here, where df, and we'll specify the column in single quote as well as in the square bracket. Item, this is the column name, and then equal equal, and the other one, then what we'll do is we'll just type mountain dash 200 space silver, comma 42, and this is it. We'll just run this code and it will say zero customer. I think I need to type the correct name here. So mountain dash 200 silver, comma space 42. So need to be clear on the exact match of the record. So this is showing as 359 and 353 as a distinct count. We will also add, sorry, we will also add display here. Display customers dot distinct, and we'll execute this. So this will run three commands. Run three commands here. One is two is the total number, and the other one is the those customers who purchased. Let's check those customer who purchased this bike. If I want to add item number here as well, we can do that. So see, this item will discuss, these are the list of customer with the item number this purchased. Next, what we'll do is we'll just do some manipulation in the data. We'll just do grouping and aggregation in the data frame. So in order to do that, what we'll do is we'll just add a new code and then name this as product sales, and then df dot select This is item and quantity. Item quantity, and then we'll use group by the item and then sum. We'll execute this and we'll see if it is executed or not. Now it's executed. We'll add another code and we'll see. We'll add product sales as a display of that. So it will display item quantity and sum of the quantity. So whatever is sale, sold higher will be displaying as. So it's just grouping by item and quantity, where we need to find out the groupings of the item by sum. Next, what we'll do is we'll just add another code to aggregate. This time we'll do the what you call it is the yearly sales related stuff. In order to do that, we need to have the SQL functions to be imported. So this is the library that we need to import. So SQL functions, I'll just use this. The best practice of using all the functions or all the imports is to use it straight on top of it. So everything that is related to import will be done. That is the best practice, to import everything on top, like the conventional programming. So this is the yearly sales. So I'll create another data frame which is called yearly sales equals df dot select, and this we'll select air, and we'll specify the column, which column is under air, and in that column I think the column is order date, and make sure you play around with the parentheses, because the whole select method will be within the parentheses. So alias, I'll rename this name as air, and then group by air dot count dot order by, and this is air. Make sure it runs. It will run, and then we can display the yearly sales. Yearly sales, sorry. There you go. We'll execute, and this will display the yearly sales for 3 years related to the total sales. Moving on, a common task for data engineering is to ingest data in a particular format or structure and then transform it for further downstream processing and analysis. So what we will do now is we will use data frame methods and function to transform some data. So we'll add another code snippet, and we will now what we will do is we will create yearly and monthly column, then we'll create first and last name fields, as well as we will reorder the columns as well. And and then what we will do is we will uh, do this transformation one by one. So now what we'll do is we'll create a new column, and this is uh, we'll give a name transform data frame equals the old data frame dot with column, and give the name air, comma, and the function air with the use, and now we'll specify the order date column. So order date, close the parenthesis all, and so this is the thing, and then we'll add another column with column and give the name, column name, month, and then month, column, call this, and then order date again. And close this. Try to run this and we'll see what happens. This is executed successfully. um, to double check, what what we can do is we can just use this display, and if we just go for just paste the data frame, it will give the column names associated with this. So if you can see here, after the original column, there are a couple of more columns added, year and month, in an integer format. We can also do display and transform df and then execute. So it will display the columns, and then you can see here this is year and this is month. After that, what we'll do, we'll create a first name and the last name based on the space. So it will not be relevant for every name, but you can do this transformation. So transform df equal transform df again, column, first name, comma, split, and first we used the the air function, and then now we're using split function, and we are specifying the column name, which column to split, and give customer name, and then comma the split function or the split value here. So what is done here is that with column there is one parenthesis, split there is another one, column there is another one. So we closed the column parenthesis, comma, split one, and then we'll do dot get data. So this is get item and dot with column, and this time we'll just replace it with last name, and then the column will remain customer name. The space will be there, the second one in the array that we will be using. So if we execute, it will be executed correctly, and then what we'll do is we'll just use display transformed df. I've just done some mistake for the transform spelling, but nevertheless, if you're giving a value, it will work. So this is month, the first name and the last name has been split as well. So this is just the basic operation that we perform. We added a new row, new columns along with that, and you can utilize the full power of the SQL library as well to transform the data by filtering the rows, deriving, removing, renaming columns, and applying any other required data modification. Now what we'll do is we'll save this transform data and add new cells with the following code. What we'll do is we'll add another code and then use this following code to transform the data and save it in the Parquet format, which will overwrite the data that already exists. So we'll use this updated one, f dot write dot mode, and this mode we specify this says append override ignore. So we'll use override. In this command we'll use the single quotation, and we'll try to save this. So this has been done. If you see this, we'll have this format, and this transform data has been saved as well. We'll just try to refresh this. So what will happen here is we'll refresh this one as well, and you see the transform data folder has been created, and in that there is an order folder which the Parquet file has been created. So this means that the transform order folder verifies that it contained the new folder name called orders, and this is in the format of Parquet files. So now what we'll do is we'll verify whether this transform data has been loaded to this particular folder or not as a Parquet file. So we'll add another code. We will um, name this frame data frame as order.df, and we'll use spark.read.format, and format can be different format, like age, big int, or something. We'll use Parquet dot load, and we'll have to specify the file path. This time we'll use the double quotation mark, and we will just copy paste the this file path. In this file path we'll use this and execute. So successfully executed. We'll add another code to display the orders.df, and then execute this. So if you see here, scroll towards down, then scroll towards the left, and new columns have been added to the Parquet file. So we are just reading straight for them from the Parquet file, which means that every time we do a transformation that needs to be saved, we save it in the Parquet file. Next, what we'll do is we will do a partitioning by year and month, so that it will create a subfolders, and only that data is saved in the subfolder to that is partitioned by the year and month. So we'll use the same logic, and I'll just copy paste this one. We are just renaming the order.df with year and month, and the mode is override, and Parquet file is this. We are creating a new folder based on that. So we'll save this. It's saying error. So our data for frame was ordered underscore df, and now it has been executed successfully. um, yeah, there you go. We're looking for partition data. This is partition data, and this has created the year folder, the month folder, and separate Parquet file for each month folder. So partitioning the data file is a common way to optimize the performance because we are dealing with a large volume of data. This techniques can improve the performance as well because it will be easier to filter the data. So for example, if you want to fetch the data related to 2021, for example 2021, so what we'll do is we'll write a code, order underscore 2021 underscore df equals spark dot read dot format, and this is the format, archive file format, and we'll just paste this dot load. And now what we'll do is we will use the this folder and see how the filters can be applied. So we'll use slash air equals 2021 slash month equals wildcard static. Let's try and execute this. So this is executed, and we'll display this, and we'll see how it goes. So this is showing as only the data related to 2021. As you can see, the year, oh sorry, if we check order date, then it will show only 2021 data related. So if you see this here in the result, the year and month is not shown because we have partitioned this data by year and month. So anything that is partitioned will not be uh, displayed in the final data frame. After transforming data using Spark and data frames, we will be working with tables and SQLs using the query as well as the data frame along with the SQL table. So the native methods of the data frame object is to enable you to query and analyze data, while many data analysts are most comfortable working with tables that they are you can they are querying using SQL syntax, and Spark provides a, a, a kind of a store or meta store in which you can define relational table as well. SQL library also provides data frame object also, which is generally based on the SQL statement to query tables in the meta store. So overall, by using these capabilities of Spark, you can basically combine the flexibility of a data lake as well as the structured data schema in SQL. So that is why it is generally based on SQL plus the Spark cluster. So moving on, what we will do is we will create a table, and in order to create a table, we'll add a code block, and on that code block, we will write df dot write dot format, and from there we will, if says like, see, asking for the parameter, so parameter will be delta, small delta dot save as table, and then we'll specify the table name, sales orders. When we run this, it will be executed successfully. We'll update the description as well. Spark.sql. If we run this, it gives the description of how the table has been placed and what is the location, what is the name of that. And if I refresh this, so it will have a new table called sales order with the description of uh, with the columns as well. Next, what we'll do is we'll go to the menu of sales order and click on load data and click on Spark. So it will copy paste. It will paste a code which will say SQL select static from the sales order. If we run this code, so it will be executed as a table and it will be displayed. Next, what we'll do is we'll use a native SQL query to execute to fetch the details about the tables. In order to execute native SQL, we'll write a command that is called SQL percent %SQL, and then we will be able to write select static from. Copy paste this, and then we'll see we'll be able to run execute SQL command. But because what it does is um, the this command at the beginning of the cell, which is called like indicates that the Spark SQL language runtime should use to run the code in the cell instead of PySpark. So if you can see here, this is called PySpark. We're running native PySpark. But if we scroll down and we'll see once we use this command, which is a magic command for using Spark SQL as a language. So this means that whenever there will be a code written here SQL, then you'll be able to run native SQL queries. After doing the SQL and running the SQL query as well as putting the data into the SQL table from a data frame, we'll try to visualize the data with Spark. So what we'll do is we will run the code. As you mentioned, this is the code as well. So we'll just scroll down and we'll just copy paste this. This time we'll just use sales order instead of the lake house, and we'll try to run this, and this will straight away display the results. So once this will be when this will be executed, there are few options. One is table, the other one is chart. So this is showing the chart related to the table itself. If you see, there are some options here. We click on this one and we will select it as by bar chart. Even if you try to select as line chart, we can do that. We can select other options as well. The key here is sales order number. So if we change this key to item and we'll see apply, we will have a better view of the chart based on the item. Values can be made as quantity, and you know instead of average we are taking as sum, and then click apply. So it is taking quantity of sum of quantity based on the items. We can do a save as image JPEG. So what it will do is it will open up it will save the image as the chart. Um, so next what we'll do is we'll use visualization using Spark with Matplot library. And in order to do that, we'll just use some resources to copy some data. So this is SQL query where it is just checking the grouping the air and um, ordered putting up unit price and quantity as well as the gross revenue based on that. And we will just execute this. Next what we'll do is, this is the SQL query. We will create a data frame. Sorry, underscore spark. This is the new data frame for the library, and we'll use spark.sql SQL query. This is the above query that we executed, and if it is has executed correctly, we will just df underscore spark dot show. After executing this will give 2019-2020 base a gross revenue based on air. Now what we'll do is we'll just use this yearly revenue and put up in a matplot library. So in order to do that, we will import a matplot library, and from that specific we'll use pyplot. Remember, I mentioned that all the imports must go on top of the code, not within that, so that we can be sure that uh, which libraries we have imported. One requirement for matplot library is that it requires panda data frame, not the spark data frame. So we'll cover up the difference between spark data frame and panda data frame in our um, upcoming videos. So for this one, we'll just convert this data frame to uh, the pandas data frame. So now we're ready to plot the data. So we'll use the PLT one, and PLT, there is a bar chart. We'll apply x-axis as the in the data frame, df underscore sales square bracket, and we'll specify the column name, order here, and then comma height equals df sales, and this is gross revenue. We'll try to execute. We're doing it one by one, which means that this is executing successfully. Apart from that, we can use plt.show as well, which will also execute, and it will show the command. So this is the basic chart that we have created. Now what we'll do is we'll just add some elements to that, so that we are sure, and we're doing some uh, what we do is we are sure, and we are we can apply the title as well as the labels as well on that. We'll use the same command to run and execute, and if you see here, the execution has been done. We will then, what we'll do is we'll just clear the plot area using this command. So this means that this is this is not executed, this is executed, but now the plot area has been cleared. So what we will do is we'll customize this chart. So first requirement is to create the chart, and then again we will use the uh, title command to say revenue by air, and then we will use plt dot x-axis label, and we will say this at air, then y-axis label, and we will say as revenue, and yeah, let's try and execute this. In the end, what we'll do is we'll use to plt dot show. So let's see what happens. So see, revenue by air, this is revenue, the x-axis is air, so it has been updating the thing. We'll add few more commands like the grid, plt dot grid, and we will specify the color equals, we can use the the 16-bit the hash code for the colors. I will use this color and see what happens. So it's giving a grid color of light gray. So, and then we will add some elements here as well. Line style, line style, sorry, just specifying whether it's a flat line or dotted lines. Just add two. Now let's execute this and see, this is converted into dotted lines. So the if we add three dotted lines, this means that it will give a error, but this is the style of the lines that we can apply. Line width equals 2. Let's execute this as well. So it has made the line thicker, and we can also specify which axis to be applied. So we have applied it. Let's apply it to y-axis only, and then this is alpha. So we need to just reduce um, the intensity of the color. It will be light color applied to it. Another thing we'll add is the x-axis rotation to 5 degree. Basically what it's doing is it's just you know tilt, giving a tilt to uh, the description of the air to make it more viewable and visible. After using the matplot library, next what we'll use is we'll use the seaborn library. While matplot enables you to create a complex chart with multiple types, it can require some complex coding as well to achieve the best results. For these reasons, we will use Seaborn library, which is built on top of the Matplotlib library. So next, we what we'll do is we'll add another code, and this time we'll import Seaborn. So this has been imported. We will just clear the plot area on safe side. This means that we are able to uh, blank run on a blank canvas. Um, then what we'll do is we'll use we'll use a bar chart, and so we'll give this name as bar x. We'll use the Seaborn library SNS bar plot, and then use the same name of the order air, comma y equals gross revenue. Make sure to change this quotation because this is sometimes confusing because we're using it in sometimes double quotations, sometimes single quotations. Data, we'll use data frame df.sales. See what happens. Oh, sorry. It has, yeah, there you go. So now with a single command, it has changed the, uh, it has using the same plot, and it's showing all the details about it. We can use we can also use a style as well. So what we'll do is we'll just use this command, sorry, sns dot set theme. There you go, set theme, and then the style equals white sensitive language. So I've used the other one. So this has updated the chart, and based on that it has applied white grid. We can also apply dark grid, and see this has changed. What I've done is I'm just creating another line, and this time I'm just using line plot. Everything else remains the same. We'll just execute this and see what happens. See, this has changed the line plot. We have set up the theme same as it is, but this is use the same. This is using the same theme, and just changing the chart type. We can go through all the commands related to Cbone by using by going through the Cbone documentation as well. Thanks for watching, and I will see you in the next video.